Okay, example 6 is a little bit more difficult because they're not in trigonometric form to start off with. So we have vector 1, or imaginary number 1, is negative 1 plus I times the square root of 3. Imaginary number 2 is the negative square root of 3 plus I. Both of those are standard form. Now, let me just say this. If I'm actually doing this problem, they want to multiply those together. This is how I would do it. Negative 1 plus I times the square root of 3 times negative the square root of 3 plus I. I'm going to FOIL. That makes positive square root of 3. That makes negative I. This makes negative 3I. Square root of 3 times itself makes 3 times I. And then that times that makes plus the square root of 3I squared. Right? Square root of 3I squared is the same as negative the square root of 3. Remembering I squared is negative 1, right? All our facts about I haven't changed. Square root of 3 minus the square root of 3 makes a real value of 0. Negative I minus 3I makes negative 4I. That is easier to do than what we're going to do. Okay? But we want to practice changing things to trigonometric form, changing things back to standard form. We're going to get some good practice in going through the process they're asking us to do. So maybe check your work with this if you wanted to verify you got a right answer, because everybody can FOIL stuff real easily. You're really good at that, right? Maybe changing to polar form is something you're not as good at, and that's things you're making mistakes in. So if you can figure out what the right answer is supposed to be, maybe on a scratch sheet of paper, but then actually do what they're asking you to do on your paper, on your homework paper, that's what I would expect you to do. So I'm just going to kind of group all that together and stick it up in the corner out of the way, like so. And we'll just keep in mind that's what the answer is supposed to be. So what they're asking me to do here is to convert the standard form structures into trigonometric form structures. So if I'm looking at z sub 1, the first complex number, my three-step process to create trigonometric form, step 1 is find the magnitude of the complex number. And we do that by taking the square root of the squares of the two numerical values here, ignoring any minus signs and i's. So negative 1 squared is positive 1, square root of 3 squared is positive 3. 3 plus 1 is 4, square root of 4 equals 2. Step 2, we find alpha. Alpha is the inverse tangent of the imaginary over the real. Again, absolute value bars, so minus signs don't matter, and don't include the I in this process. So square root of 3 over 1. If you use a calculator to do that, I want to be in degrees here. Unless they specifically tell me to use radians, I like to use degrees on these. So I'm going to do inverse tangent of the square root of 3. That comes out to 60 degrees. The magic numbers for tangent on your sheet are 0, 1, square root of 3, and the square root of 3 over 3. Any one of those four show up. There's an exact value on that sheet. So if you happen to know those, great. If not, again, your calculator can get those for you. All right. The last thing I need to establish is a quadrant. And quadrants established by direction. So negative 1 takes me left. Positive square root of 3 takes me up. If I'm in the coordinate plane here and I go left and up, I'm in the second quadrant. So for this vector, theta is going to be 180 minus alpha, so 120 degrees. So the reference angle helps us find the actual angle. The actual angle is based on the quadrant. In the second quadrant, the relationship 180 minus alpha. So my vector number 1 is 2 CIS 120. Vector 2, same deal. So I'm going to square root of both of these things squared. Square root of 3 squared is positive 3. This is 1i, so 1 squared is 1. Again, ignore the I when you're doing this. The numbers matter, so square root of 3 and 1 matter. 3 plus 1 is 4, square root of which is 2. Alpha equals the inverse tangent of the absolute value. So again, ignore minus signs. 1 over the square root of 3. That's also known as the square root of 3 over 3. Hopefully we can recognize that. I multiply top and bottom by the square root of 3. So again, that's one of the magic numbers on our sheet. Again, my calculator knows the answer. Inverse tan 1 divided by the square root of 3 comes out to 30 degrees. And And finally, if I'm looking at this vector, negative square root of 3 takes me left, positive 1i takes me up. Again, I'm going left and up. I'm again in the second quadrant. So once again, my rule for theta is going to be 180 minus alpha, 150 degrees. So vector 2, or imaginary number 2 in trigonometric form, magnitude 2, angle, CIS, angle of 150 degrees. So we convert both standard form vectors, or imaginary numbers, into trigonometric form. And once I get trigonometric form, now I'm allowed to apply that rule. Looking for something, CIS something. I'm going to multiply these together to get the magnitude. 2 times 2 is 4. I add the angles together to get the angle. 120 plus 150 is 270. And that's the trigonometric form answer. They asked for the answer in standard form. So I want to convert back to standard form. And again, CIS just means cosine plus I sine. So I want to do 4 times cosine of 270 plus I sine of 270. The cosine of 270 is 0. The sine of 270 is negative 1, so plus negative 1i, so minus 1i. If I distribute the 4 through, 4 times 0 is 0, 4 times negative 1i is negative 4i. There's our standard form answer. Obviously this was quicker, but being able to do that is going to be important, so make sure you're practicing the skill. The more you practice, the quicker you get. This right here, for most people who practice it, takes about 30 seconds to a minute to do all 3 of these steps. Once you get accustomed to what you're supposed to do, when you're supposed to do it, the calculator is doing all the calculations for you, so it's just a matter of knowing what you're supposed to type in. That takes very little time, really, when you're not sitting up here explaining to everybody how to do it. You just set it up and do it pretty quick.